Hello students, welcome you all for PRP lecture videos. In this video, we are going to see the continuous distribution. See, in this one, the exponential distribution. What is exponential distribution? So, the exponential distribution describes the time between events in a process where events happen randomly and independently. See, every event happens randomly, doesn't depends on the other one. Okay, the average rate lambda is a constant. For example, throughout the day, for each and every 1 hour or 2 hours, a particular interval, this number of phone calls or number of events, the average is lambda, that is a constant. The process has the memoryless property. That means the probability of an event in the next instant does not depend on how much time has already passed. See, this one is very important. Already we have seen in discrete random variable for geometric distribution. So discrete, geometric, for continuous, exponential, both are having memoryless property. See one example. Time between incoming phone calls at a call center. All calls arrive randomly throughout the day. Does not depend on others one. On average, there are 12 calls per hour. For example, average 12 calls per hour. Okay. So we want to model the time between two calls. So first call and second call. In between these two, there is a gap. We have to model you based on this exponential distribution, based on the three conditions. What is the three condition? Events happen randomly and independently. So, for example, 10 to one phone call arrived. If 10 to phone call arrived, doesn't change the 10-3 arrival. So 10-3 is a different call, 10-2 is a different call. Okay. Second, average rate lambda is a constant. In this case, we have assumed average rate lambda equal to 12. Okay. So per hour 12 calls, per minutes 0.2 calls. So what is the time between two calls? 1 by lambda equal to 1 by 0.2, that is equal to 5 minutes. So every 5 minutes, for example 0 to 60 minutes, every 5 minutes we have one phone call. That is a concept. So for 5 minutes one phone call means 12 into 5, 60, 1 hour 12 phone calls. The memoryless property. Already told you, if the probability of even waiting for another 2 minutes is exactly the same as it was the start. See, 0 to 60 minutes, 0 and 5 and 10. Already 5 minutes is over. See, for every 5 minutes one phone call arrived. Suppose waiting for 2 minutes. What is waiting for 2 minutes? Already 5 minutes is over. So we have to look at only the 2 minutes. Already 5 minutes is over. There is no phone call again will come. Okay, so we need to wait only 2. The probability depends on only this waiting time 2 only. Okay. Now let us see the definition. A continuous random variable x is said to follow an exponential distribution with a parameter lambda greater than 0. So its probability density function is given by f of x equal to lambda into e power minus lambda x, where x greater than or equal to 0, 0 otherwise. How do we define in number line? See this, in number line minus infinity, 0 and infinity. Here the probability density function is defined only the positive values 0 to infinity. So in this case alone we have lambda into e power minus lambda x. In this negative side we don't have the function. What is the answer? 0. So here x is called exponential random variable, also continuous random variable. Note this one, exponential distribution is also known as negative exponential distribution. Okay. See the important one, moment generating function. Hence we have to find mean and variance. So mean and variance will be found in other way also. But after finding moment generating function, let us use this concept to find out mean and variance. Okay. So mx of t, what is the formula? Expectation of e power tx. Okay. So if it is exponential function of any function, for the continuous random variable, integral the function into f of x dx. Okay, here what is the function? E power tx. What is f of x? Lambda into e power minus lambda x. Okay, so here see e power tx, e power minus lambda x. Both base is same. Okay, so we should add the power alone, tx minus lambda x. Let us keep the power minus, so that taking minus common, minus into lambda minus tx. So inside the simplification, lambda into e power minus lambda minus t into x. Hence lambda is a constant, we can take it outside. Inside we have the integrand e power minus lambda minus t into x. See, the simplification is, see, lambda is a constant, e 0 to infinity, e power minus lambda minus t into x into tx. Okay, so what is the answer? For every exponential integration, same, e power minus lambda minus t into x divided by, what is the coefficient of x? Minus lambda minus t. I will apply the limit 0 to infinity. So minus lambda by lambda minus t into, apply the upper limit infinity here, e power minus infinity, minus apply lower limit 0, e power minus 0. So minus lambda by lambda minus t, 0 minus 1, here minus into minus plus, lambda by lambda minus t. So what is mx of t? That means moment generating function is lambda by lambda minus t. Okay. Now we are going to find mx dash of 0. So mean formula is expectation of x equal to mu1 dash. So mu1 dash is equal nothing but first derivative of a moment generating function at time t equal to 0. First derivative of moment generating function at time t equal to 0. Okay, so here mx dash of t, what is the formula? V u dash minus v u dash divided by v square. Since our moment generating function is lambda by lambda minus t, or you may use another formula. Since lambda is a constant only, now use the constant 1 by x differentiation formula minus 1 by x square. We may do like this also. Now I am going to use the quotient rule, v u dash minus u v dash divided by v square. Here what is u? U equal to lambda, u dash value 0. What is v? Lambda minus t, v dash t equal to minus 1. Since lambda goes to 0 and minus t becomes 1. Okay, now substitute here 0, lambda minus t minus u value lambda, v dash value minus 1, minus into minus plus lambda by lambda minus t whole square. Evaluate t equal to 0. Substitute t equal to 0 here, lambda by lambda square, that is 1 by lambda. Hence e of x equal to 1 by lambda. Next, variance. We know the variance formula. Variance of x equal to expectation of x square minus e of x whole square. So already we have known e of x. Now we have to find e of x square. See, mx dash of t, what is the answer? Lambda by lambda minus t whole square. Okay, so e of x square is nothing but mu2 dash, that is second derivative of mx of t at t equal to 0. So what is mx double dash of t? I am going to consider this is what u, this is what b. Okay, so u equal to lambda, what is u dash? 0. B equal to lambda minus t square. So first differentiate the square, 2 into lambda minus t. Then differentiate lambda minus t, it's come minus 1. So minus 2 into lambda minus t. So substitute here 0, lambda minus t square minus lambda into minus 2 into lambda minus t. Okay, divided by lambda minus t whole square, again square. Minus to minus plus 2 lambda, lambda minus t. Cancel this one, we have cube. Now substitute t equal to 0. What happened? 2 lambda by lambda cube. So answer 2 by lambda square. This is only for e of x square. Now variance of x formula. E of x square is over. E of x already know. Substitute here 2 by lambda square minus 1 by lambda whole square equal to 1 by lambda square. Okay, so hence mx of t, MGF equal to lambda by lambda minus t, mean value equal to 1 by lambda, variance of x equal to 1 by lambda square. In this next video, let us see some examples and also memory less property. Thank you.